to factor. When we factor, here's an expression. There's no equal sign. I'm not substituting a value for x and then evaluating. To factor means to look at the two groups and ask myself, is it possible that I can divide the same number out of both? And in this case, that is. I can factor to 4 and I'd be left with 1x plus 2. Now, you can check to see if you did that right by going 4 times 1 is 4 with an x, bless you. 4 times 2 is 8, and there's a plus sign. Okay, I factored out a 4 correctly. Here I have 5x minus 15. I can factor out a 5. 5 times 1 is 5 with an x, there's a 1 and x, and 5 times negative 3 is negative 15. Factoring is just another way to rewrite things. Factoring allows us to condense things. Now, the opposite of when we have it in factored form is for us to expand the expression. So we're going to expand using something you've probably learned called FOILing. F stands for front, outside, inside, last. So when I look here, I start with the F for fronts. 3 times 5 is 15, and there's 2 x's. O stands for the outside. 3 times positive 4 is 12, and there's 1 x between those two groups. I stands for the inside. Negative 2 times 5 is negative 10, and there's 1 x. And L for last. Negative 2 times positive 4 is negative 8. So there's 4 terms when I FOIL, and now I go back and I combine like terms. These are different signs, so I subtract, and I keep the sign of the larger number. This is expanded form. Expanded form, and then when we factor, I was provided you this expression in factor form, it's condensed. Okay, let's expand this. Once again with FOILing, 3 times 4 is 12. There's 2 x's. How did I know which ones to do? F stands for front, so I'm multiplying these two. Then I'm going to do the outside. 3 times negative 1 is negative 3 with an x. Going to the inside, positive 2 times 4 is positive 8 with an x. And multiplying the last. 2 times negative 1 is negative 2. So I have 4 different terms. I'm combining like terms. 12x squared, they're different signs, subtract, keep the sign of the larger number. This is equivalent to this. They're just different forms. This is expanded form, and this is condensed form. It's in factored form. If you struggle today, there's a decent chance it may be because you do not have strong number sense. You're not great with your multiplying. If that's the case, I've asked this before and I have not done on my part. I'm going to put together today before I leave some worksheets on adding, subtracting, multiplying, dividing positives and negatives for you to continue to work on that skill. All right, now these look different. So example 3 and example 4, they're both in factored form, but what's different than example 1 and 2 is we see the exact same thing in parentheses, but the only difference is 1 is subtraction and 1 is addition. It doesn't matter if subtraction comes first or second. The only difference in the parentheses is 1 is subtraction, 1 is addition. So here's the key. There's a shortcut. When they're exactly the same, only the sign in between is different, we get to skip out on doing the O and the I because they would just cancel each other out, and we only have to do the front and the last. Front would be 4 times 4 and 2 x's. Last would be negative 5 times 5, which is negative 25, and we're done. Again, front, 2 times 2 is 4, and 2 x's, and last, negative 1 times 1 is negative 1. There's a shortcut that can only be used when you have the exact same parentheses. The only difference would be the signs in between. All right, what does this look like? Let's flip to the front now. And as I shared before I started this video, I attached this to Teams. So I'm going to ask that you refer to this on your phone or computer as we go throughout today. Each one of the expressions I provide you is in expanded form, and we want to condense it. In factored form, it needs to be simplified to the fullest. When you don't see a number in front, there is a 1. So the first thing I do is I look at the numbers, 1 and 25, and then I come back to the perfect square list. So each of the numbers to the right of the equal sign are perfect squares. The numbers on the left tell you how to achieve that perfect square. Example, 16 is achieved by taking 4 times 4. 400 is 20 times 20. So I want to know, is 1 and 25 on this list? Yes, 1 is 1 times 1. 25 is 5 times 5. Perfect. This is going to break into 1 times 1 and 5 times 5. Now, in order for us to do this difference of squares, we have to have subtraction on the inside. So subtraction needs to be in between. What do we do with this a? We're going to take whatever the exponent is, and it has to be divisible by 2. So I'm going to divide it by 2. I'm going to equally break it apart. 2 divided by 2 is 1. So each one of those is a to the first. Now I'm going to fill in my blank spots. Think of this as 2 halves. We have a front side, so anything to the left of the subtraction sign is in front, and anything to the right of the subtraction sign is in back. So if I was going to classify this, I'd say, okay, the 1s and the a's are in front and the 5s are in back. Since 1s and a's come from the front, they're going to remain in front, and the 5s are in back. Each 5 goes in back. In between the two groups, one will have an addition sign and one will have a subtraction sign. We just factored this expression. This expression is now rewritten in condensed form as 1a plus 5 and 1a minus 5. Let's go on to example number 2. We have subtraction. Now let's look at the numbers, 49 and 100. Okay, come off to the side. 49, good. 100, good. So 49 is 7 times 7. 100 is 10 times 10. So this breaks apart. Please make sure you're showing all your work into 7 times 7, 10 times 10. And now I'm going to break apart that b. So I'm going to look at the exponent and divide it by 2. 2 divided by 2 is 1. The 7s came from the front, so they have to be in the front of both parentheses. The 10b's came from the back, so they have to be in the back of both parentheses. One is addition and one is subtraction. You may be asking yourself, like, okay, so I do this, but how do I know I did it right? Notice these parentheses are identical except for one's addition, one's subtraction. If I FOIL this when they're exactly the same except for the sign in between, you get to skip the 2 operations in the middle. So the front, 7 times 7 is 49. 10 times negative 10 is negative 100, and there's 2 b's. This is the same thing that we started with. Let's go on right now to example 3. I have subtraction in the middle, so I can keep moving on. And I'm looking at a 9 and a 256. Okay, let's see if 9 is here. 9 is here. 9 is 3 times 3. 256 is 16 times 16. So 3 times 3, 16 times 16. And now I'm going to take the exponent on the c, I'm going to divide it by 2. If you don't feel comfortable, make sure you have a calculator at your desk. If you don't feel comfortable, you're just going to grab that calculator and take 2 divided by 2. You get a 1. So c to the first and c to the first. The 3's and the c's are in front. I know they're in the front because they're to the left of the subtraction sign. The 16's are in back. It does not matter which one you put a positive in and which one you put a negative, as long as one's positive and one is negative. We're going to go on to example number 4. Now the key here is when you factor, you always have to divide out the maximum number. So if I come back here and I look at this, I'm just showing an example of when it's not totally factored. So if I was given this expression and I thought, hey, I can divide both of these by 2. 2 times 2 is 4. 2 times 4 is 8. These are different. Yes, they are equivalent to the same thing, but I didn't fully factor out the maximum amount. To be fully factored means we take out the maximum amount. Let's look at 324 and 16. 324 and 16. Okay, I'm going to come off to the side. 324 is right here. Okay, good. And 16 is right here. All right, here we go. 324 is 18 times 18. 16 is 4 times 4. Again, I'm taking this d, which is d squared, When I take the square and divide it by 2, I get d to the first and d to the first. The 18 and the d's come from the front. The 4's come from the back. But there's a problem here. This is different than examples 1, 2, or 3. And how is this different? Because 1 and 5, I can't factor anything else out. 7 and 10, I can't factor out any other value. 3 and 16, there's no number other than 1 that factors out. But 18 and 4 are both divisible still by 2. So I'm going to take this portion and I'm going to factor out a 2. So there's a 2, and I ask myself, 2 times 1 quantity is 18. 2 times what quantity is 4? And now I'm going to do the exact same thing to the second parentheses. Again, I can factor out a 2. 2 times 9 is 18. 2 times negative 2 is negative 4. When I combine like terms, I'll leave the parentheses just as they are, but the 2's are going to be multiplied. 2 times 2 is 4, and here is my final answer. Moving on to example number 5. In example number 5, I have 5 subtract 20 f to the second. So wonderful, I have subtraction in between. That's great. But I have a 5 and a 20, so I look up above, and the mistake sometimes students make is they go, yeah, there's a 5 here, and yeah, there's a 20 right here. We are looking on the right side. The perfect squares are on the right side. So there is no 5 and there is no 20. Why is that? Because I can't think of two numbers that are exactly the same, whole numbers that multiply to give you 5, and two numbers that are exactly, like 2 times 10 is 20, but 2 and 10 are not the same number. So what are we going to do? You're going to circle the smaller of the two numbers and write it off to the side. Now I'm going to identify what numbers nicely divide into 5. 1 and 5. Take your calculator. If you don't have one, please go grab one. And I'm going to ask myself, what numbers here would be the largest that divides into 20? So I start with 20, and I'm going to first divide it by 5. And you can do mental math. Okay, I divide. So I can divide this number by 5, and I can divide this number by 5. So let's factor out a 5. 5 times 1 is 5. 5 times 4 is 20. 5 times 1 is 5. 5 times 4 is 20. I brought down the subtraction sign and the f squared. Now I'm going to go back and I'm going to look at these two numbers. Can I find 1 and 4 above as perfect squares? 1 is equivalent to 1 times 1. 4 is equivalent to 2 times 2. 1 times 1, 2 times 2. I have subtraction, so I can keep going. And when I divide that exponent, I get f to the first and f to the first. Ones come from the front, so 1 goes into each of these areas. It comes from the front. 2's and f's come from behind, so 2 and f goes in back. One of them is addition, one is subtraction. I could have made subtraction first and addition second. It does not matter. Now, pretend for a second that you had a scissors. And I put, again, if you're a tutor, make sure you have a paper and back so you can work with the person next to you. And I asked you to cut out around each of these terms. You cut out around negative 12 x squared. You cut around positive 75. And we're just going to rewrite them. Because we learned in math that 3 times 5 is the same as 3 plus 5 is the same as 5 plus 3. 3 plus 5 is 8, and 5 plus 3 is 8. So I can rewrite this and not change the expression. I can put positive 75 first and negative 12 g squared second. Now 75 and 12, I go up above. 75 and 12. Okay, 75, no, it's not there. 12 isn't there. Okay, what do you do next when they're not up there? You select the smaller of the two numbers, which is 12, and I'm going to write 12 off to the side. And if you don't have great number sense, I'm going to show you how you can use a calculator to make this list. So 12 divided by 1, okay, that works because I have a whole number, so 1 and 12. 12 divided by 2, if I get a whole number, then I consider it. Okay, so 2 and 6. 12 divided by 3, that works. 3 and 4. And so I've already listed all the numbers that nicely divide into 12. You choose the smaller of the two numbers. Now, what do you do with this list? We want to see, can we factor out something? Are we able to factor out something? Like we factor out a 4 up above in the end. So I always start with the largest number. And so I hit the bigger number here, 75, and I'm going to divide it by 12. If I don't get a whole number, I cross it out. Doesn't work. 75 divided by 6. It doesn't work. 75 divided by 4. Nope. 75 divided by 3. It works. So 3 divides into 12, and it also divides into 75. Let's factor out a 3. 75 divided by 3 is 25. Bring down the subtraction sign. 12 divided by 3 is 4. Bring down the g squared. $25 breaks into 5 and 5. 4 breaks into 2 and 2. We have subtraction. And I can break g divided by 2 into g to the first and g to the first. 5s come from the front, so they must remain in front. The 2's and g's come from the back. They must remain in back. 1 is positive and 1 is negative. Let's move on right now to example 7. Now the first thing I see is I don't have subtraction. So I'm not going to be able to factor in the same way that I've done previously. It's going to have to be a little bit differently. So I find 63 and 28, and maybe I don't recognize the subtraction sign, and I'm like, oh, 63 is not here, 28 is not here. So then I am going to go with the smaller of the two numbers, and again, if you don't have great number sense, you're taking this and you're going, okay, 28, I know 1 and 28 work, because 28 divided by 1, you can see works. 28 divided by 2, so I'm going to write down the numbers. I have 1 and 28, I have 2 and 14, and I have 4 and 7. And how do I get those? Because when you divide by 3, it's a decimal. So 28 divided by 4, we can see it works. Just working our way in. And I go one by one now. I start with the larger of the numbers. I divide it by 28. Nope, doesn't work. Divided by 14, it does not work. But when I divide 63 by 7, we can see I get a nice whole number. So I'm going to factor out a 7 to get 9h squared plus 4. When I distribute this, I should end up with this exact same expression. Why can't I go further? Why can't I go 3 times 3, 2 times 2, h and h? Because this is not subtraction. I have gone as far as I can. Let's go on to number 8. Number 8, 50 and 18. The very first thing we do is we come up here and we go, okay, 50 is not on here, 8 is not on here, got it. So what do we do next? We're going to go to the smaller of the two numbers, is 18, and I'm going to identify what goes into 18. Okay, I know 1 and 18 work. And again, if you don't have a great number sense, divide by 2. Okay, that works. I write them down. Divide by 3, that works as well. So I've listed all the numbers. Once I've made the list of the numbers that nicely divide into the smaller number, in this case 18, then I'm going to go through and choose the larger number, which is 50, and I'm going to start to see, do any of these also divide into 50? I want the largest. Divide by 18? Nope. Divided by 9? No. Divided by 6? No. Divided by 3? No, but when you divide it by 2, it does work. So I can go 2. Let's factor out a 2. 50 divided by 2 is 25. 18 divided by 2 is 9. How do I know if I am able, in this case, how do I know if I am able to move forward here? Well, this number is on the list of perfect squares because it's 5 times 5 is 25. This is on the list of perfect squares. You will be allowed to use that list. 3 times 3 is 9. And I can take the exponent, which is 2, and divide it by 2. 2 divided by 2 is 1. And lastly, I have subtraction. Before we turn our paper over, let's go ahead and let's factor this. 5's come from the front, 3 j's come from the back, 1 is positive, 1 is negative. It doesn't matter which positive and which one is negative. Flip to the back, please. We are almost done with what is considered Algebra 1, Algebra 2 concepts, and then we're going to build upon it the Algebra 3 level. So 8 and 40, this is all stuff that you probably spent an entire month doing in Algebra 1, 2. I used to teach the course many years ago. So 8 and 40. So I look over here, 8 and 40. 8, no. 40, no. What do I do then? I choose the smaller of the two numbers, and I write down what divides into 8. 1, 2, 4, and 8. How could I do that if I did not have great number sense? Obviously, dividing by 1 works, dividing by 2 works, and you'd see that only 1, 2, 4, and 8 work. What do I do with that information? I take the larger of the two numbers, and first I'll divide it by 8. Oh, I can divide out. Okay, so let's divide 8 out of both. 8 times 1 is 8 with a k squared. 8 times 5 is 40. I brought down the negative sign and the k squared. You're going to see that in this problem, I actually cannot move any further. I have subtraction. This breaks into k and k. This breaks into 1 and 1. But look at this list. We can see that 5 is not a perfect square. Everything must work for us to break it down further. 1 times 1, that works. K times k, that works. We have subtraction. I don't know a whole number that when I take it times itself, I end up with 5. So like 2 times 2 is not 5. 3 times 3 is not 5. You can't say 1 times 5. They have to be the same number. This is as far as we can go. 392 and 18. 392 and 18. 392 is, okay, right there. 18 is right here. They are not perfect squares. So I go with the smaller of the two numbers. And now I'm going, what goes into 18? 1 and 18, 2 and 9, and 3 and 6. I'm grabbing the calculator. And I'm taking the larger of the two numbers, and I'm dividing 18 all the way down. So 392 divided by 18. It's a decimal, doesn't work. 392 divided by 9. 392 divided by 6. 392 divided by 3. 392, whoops. 392 divided by 2. That works. So that means I need to factor out a 2. So take 392 divided by 2, you get 196. 18 divided by 2 is 9. How do you know if you can go further? Well, you have to have subtraction here in the middle. I'm good. And now I'm going to find, is 196 a perfect square? 196 is a perfect square. 14 times 14. 9, is 9 a perfect square? 9 is a perfect square. It's 3 times 3. M divided by 2 is M times M. Okay, you ready? 14's going front. 3 M's going back. 1 is addition, 1 is subtraction, and we're done. All of that is the Algebra 1, 2 concepts. So thank your Algebra 1, 2 teacher if you feel like they did an adequate job teaching you. Now we're going to build upon it for Algebra 3. So Algebra 3 is the same concept. There's only one small difference. Now we have multiple variables, but the same thing applies. Find 25 and find 4. 25, okay, that works. 4, that works. So 25 is 5 times 5. 4 is 2 times 2. That all works. Okay, ready? Next thing is we want to take these exponents and we're going to divide them by 2. Like we're going to split them in half equally. So 6, if you split it in half, you end up with 3 and 3. And 10, if you split it in half, you end up with 5 and 5. You have to be able to split it in half equally. All right, you ready? So in front, I have 5's and n's. In back, I have 2's and p's. 5n to the third, 5n to the third. In back, I have 2p to the fifth, 2p to the fifth. 1 is addition, 1 is subtraction, and we're done. We just rewrote this original expression in condensed form. It's called factored form. Next, we're going to go on to example number 12. Example number 12, if you have a second, look back at example 6 really quick. Look back at example 6. Example 6 is like example 12. Hypothetically, I would say, okay, take out, and we'll learn later when you don't have to move these, but take out and cut out these tiles, and then we're just going to rewrite them. As a reminder, A plus B is the same as B plus A, right? You can switch the order when you're adding. So I'm going to put the positive 121 in front, and the negative 9Q in back. 121 and 9, go back to that paper. 121 and 9, are they both perfect squares? 121, let's check. Is 121? It is. 121 is 11 times 11. And 9 is 3 times 3. 11 times 11, 3 times 3. So I'm going to make my 2 parentheses. And then we're going to cut that R in half. If you cut 14 in half, you're left with 7 and 7. If you cut Q in half, you're left with Q to the 8th and Q to the 8th. They have to add up to 16 and add up to 14. The 11s and the R's come from the front. The 3's and the Q's come from the back. So 11 R's stay in front. 3 Q's remain in back. It does not matter which one you make positive and which one you make negative. So I can make the first one negative and the second one positive I wish. They just have to be different signs. Let's move on to number 13, please. Number 13. Can we find 72 on the list? Let's look. 72. 72, not on the list. 162, not on the list. Okay, what do we do next then? Well, here's 72. It's not on the list. 72 is not on the list. But I want to come up with all the numbers nicely go into it. So 1 and 72. Now, if you don't have great number sense and you're like, well, what do? I just don't know those numbers. Okay, then bring this back up. Let's divide it by 2. If I get a nice whole number, then I need to include both of these numbers. So I need to include 2 and 36. Divide it by 3. If I get a nice whole number, like I did, I need to include 3 and 24. Divide it by 4. I need to include 4 and 18. You're going to see here I do not get a nice number when I divide it by 5, so I do not include 5. When I divide it by 6, I get 12. I include 6 and 12. I'm running out of space here, so I'm going to put a little parenthesis here, 6 and 12. And then lastly, let's do divided by, I know 7 doesn't work, but 8 does work, 8 and 9. So here are all the numbers I have. 72, 36, 24, 18, 12, 9, 8, 6, 4, 3, 2, 1. Start at the very highest number, and now we're going to focus on 62. 162 divided by 72 does not work because it's a decimal. 162 divided by 36 does not work because it's a decimal. 162 divided by 24 does not work because it's a decimal. 162 divided by 18 works. So how do I know which one I am factoring out? I tested 18 and 18 worked. So I'm going to factor out an 18. So I'm going to take 72 divided by 18 is 4. 162 divided by 18 is 9. And I want you to beat me right now. You have 30 seconds to finish this problem. Go. So I have 2s squared, 3t to the 6th, 3t to the 6th, 1's addition and 1's subtraction. Okay, you ready? I want you to do 14 on your own. You have 30 seconds to begin. 9's go in front, u to the 6. 4's going back, v to the 10. 1's addition and 1's subtraction.